So hi everyone, today we are working on graphing parabolas. Again, graphing parabolas. But we're doing it in a fast, super fast way, okay? Super fast way. We're gonna look at some characteristics we're gonna practice on IXL, and then we're gonna go forward and backwards today. We're not gonna only able to draw the graph, we're going to be able to write the equation also. And this will be in our special, what we call vertex form. So let's go ahead and introduce that to you right now. So we're going to use today, we're going to call it vertex form. And if you remember what the vertex is of a parabola, the vertex of a parabola is this special point right there. That's my vertex. And we're going to call this letters x and y, right? That's x and y value, but we're going to call this using special letters for us for this special equation, h and k. Now, in algebra, we learned all these different variables mean different things. If you remember for a very basic line, if I talked about a line, let me draw this on the left bottom here, a line equation, we said the equation of a line was y equals mx plus b. And as long as you knew what m and b were, you were able to draw that line in literal seconds. We didn't have to make a table. We didn't have to do anything special except know what those characteristics were. He's tall and rich, right? So if I say m was our slope, okay, so our characteristics are our slope and the y-intercept. We'll take a quick example here. So if I told you y is equal to 3 over 2 x plus 1, if I know what m stands for, which is the slope, and the b is the y-intercept, I can tell you where to start. We start at 1, and the slope is rise 1, 2, 3 over 2, and we can draw a line and really just as fast as I can count the steps. And hopefully you guys will remember how to do that. If you forgot, it's probably good for that you guys go review this. Now, I wish I could draw something that fast for a parabola, because yesterday when we did drawing parabolas using a table, it took us forever. We had to do at least 4 points or 5 points, and then we had to do a lot of math. Now, is there a way for us to graph parabolas the same way? And the answer is yes. And in this vertex form, we don't have y equals mx plus b. We have more characters, of course, because this is a harder problem. So we have more stuff to worry about. So here we go. We're going to say our vertex form is y is equal to a x minus h squared plus k. Now be aware that's a minus h, and I see a plus k here, okay? And as you've seen here, we mentioned before, we have h and k. That's going to be our vertex. And we have this new letter a. And this a is going to change the shape of my graph. I'm going to change the shape of my graph. Okay, so what we're going to do here is I'm going to give you an example of what a couple of versions of this, and then we'll see how that works. Okay, so this is our main value right here. Just like y equals mx, you guys need to really remember this vertex form, and this will help us graph graphs in literal seconds, okay? Not minutes, not grinding it out, seconds. I'm not kidding about this. Okay, so let's go ahead and look at a couple of versions of this. Y is equal to 3, no, let's not do, let's do x, 1x minus 2 squared minus 1, okay? Another graph we're going to do is y is equal to 2x minus 2 squared minus 1. And then we'll do one more here. I'm going to move this around. Y is equal to 3x minus 2 squared minus 1. Okay, I have 3 graphs here. Let me rewrite the second one to make it look a little nicer. Give me some space. Y is equal to 2x minus 2 squared minus 1. Okay, so we have 3 equations. They look very similar to each other. I want us to write down the 3 characteristics. Tell me what the A, what your H, and what your K is. What your A, what your H, and what your K is. What your A, what your H, and then what your K is. Now, our formula again, let me rewrite it in case you don't have it, is y is equal to a x minus h squared plus k. So using our algebra skills, we have to make sure like we keep our negative signs and we don't lose them. So what would A be for our first problem? Well, A is just a different number. That's a 1. And oftentimes, if we don't have anything, that's an invisible 1. So if I wrote it as x minus 2 squared plus minus 1, if I don't write anything, that's always going to be an invisible 1. 1 by default. Now, what is the h value? If you notice that there's a negative sign here, there's a negative sign, we're going to leave the negative sign alone, and we're just going to take the 2. And the k has to be positive in the back, so this is actually a negative 1. So take a look at how I did that. If I wanted to plug everything back in, just to check, a x minus h squared plus k. If I plug in 1, 2, and negative 1, 1 x minus 2 plus negative 1, that gives us a minus 1 at the end, okay? So just be aware that when you're taking out values, you're taking out that negative with it. Some cases, with the h, you can leave the negative because the negative is already there. It's like showing up to the dentist's office, and aren't there a bunch of magazines that are already there? You don't take them with you, you leave them there. That negative sign is there, you leave it there. Okay, how's it different from the next one? The only difference is that now that's a 2. Now I want you guys to make sure you guys caught the h. What type of h is that? Is that going to be a plus 2 or minus 2? Would that be a plus 2 or minus 2? Remember, the negative is already supposed to be there, so we're just going to take a positive 2 there. And the k is positive, so I'm going to take the negative 1 with me. Bring your trash out, take your trash out with you. Let's look at the next one. We see a 3. My h is 2, and my k is again negative 1. So the big deal is just understanding what values we have. Are they going to be positive or negative? Because the next part is, these are going to just hop right onto the graph. So the h and k are what we call the vertex. So the vertex is h and k. So h and k here is going to be 2 and negative 1. And what does that translate to the graph? That's the center of the graph, right? That's the center of my graph. That's where the parabola meets. So great, let's go ahead and start graphing this, and we'll graph it as, we'll draw 3 graphs here. Okay, so the first one, we said our vertex is, take a look at the vertex, is 2, negative 1. 2, negative 1, whoops, and 2, negative 1. So all these graphs, I'm going to graph on the same spot. 2, 1, 2, down 1. That is my vertex. 1, 2, down 1. 1, 2, down 1. Okay, 1, 2, down 1. That's it. That's the vertex. That's the center of the graph. Now I can tell you this graph is going to look something like that. Bam, bam, bam. That's, you know what? 99%. I'm pretty darn close. So if you want a little more accuracy to the graph, that's where the a value comes from. And let me go ahead and demonstrate you to you what the a value does. So on Desmos here, I have this exact same equation written out, x minus 2 squared minus 1. And you can see the vertex is at 2, negative 1. Now, here's the next part I want to show you. I'm going to zoom in a little bit. Okay. Okay, there. One more thing, let me make it a little bigger. Okay. The a value is currently at 1. And I want you to make note that it's at 1. So here is how we count. 1 space over, okay, 1 space up. That is how we count our parabola. It can be super easy as that. 1 space over, 1 space up. 1 space over to the left is still 1 space up. Okay, it's a little hard to see, but that's going to be 3. Let me zoom into so you guys can see that's 3. Okay, that's 3. If a is 1, that's 1 space over, 1 space up. That is your parabola. 1 space over, 1 space up. That's your parabola. What if a was 2? If a was 2, well, let me change this for integers. Okay, if a was 2, let's see. If a was 1, a was 2. A was 1, a was 2. What happens to my graph? Does it get wider or narrower? As A gets bigger, the graph gets narrower. Now, why would it get narrower? I want you to think of this as money. Okay, think of this as money. If I thought about this as money, imagine if I doubled your paycheck, or I tripled your paycheck, or I quadrupled your paycheck. So instead of making money slower, wouldn't you make money faster and faster and faster? The idea is, if it curves earlier, you're increasing quicker. That's right. So if A is a bigger number, your parabola isn't going to slow down, it's going to speed up. And you want to realize that for every step you take, you're making more money faster. So when A is 1, one step over means one step up. But if A is 2, it's one step over, and then let me switch it, one step over, and then we're going to take 2 steps up. It's going to be even more narrow. If A was 3, one step over, 1, 2, 3 steps up. Going the same way on the other side, one step over, one step up. Yeah, that was easy. If A was 2, that means I'm doubling your speed. Now your graph is twice as fast. So one step over would be 2 steps up. That's even faster. If A was 3, one step over would be 3 steps up. One step over would be 1, 2, 3 steps up. That's even faster. That's even more narrow. So as A becomes a bigger number, the graph becomes more narrow. But the cool thing is that we can graph it by just taking that first step. That first step already tells me how narrow that graph would be. Now, we're going to take a look at Desmos real quick. Sorry, not Desmos. We're looking at IXL. So let's go back to your IXL real quick. So you guys are going to do a bb.5, bb .5 here, and bb.5 for algebra is right here. I want to show you guys how fast, if you guys can catch it. If you look at this graph, it kind of looks like our form, except it's just x squared, okay? And we're just going to start with x squared. The A value in front is an 8. So the vertex, and we'll go over this in a little bit, but I want to show you guys how fast this can be. If my vertex is 0, 0, the parabola, where is it going to be? Is it going to be super wide or super narrow? Imagine if I 8 times your grade, if I 8 times your paycheck, if I 8 times your allowance. Do you think you're going to make money faster or slower? Hopefully you're telling me you're going to be making faster. And this is how fast we do it. We take, thank you, we take one step over. We go 1, 2, 3, 4, 5, 6, 7, 8. This is our graph. Because it's super narrow, because your graph is 8 times as fast. The vertex is 0, 0, 8 times as fast. Submit. Got it. The next one is, this is a negative. What do you think a negative does to my graph? If the A value is negative, it's not going to go 7 times up. It's going to be 7 times down. This is like the stock market. You could gain 7 times up, but you could also lose 7 times down. So the vertex is 0, 0, and we're going to count 1, 2, 3, 4, 5, 6, 7 down. So on your IXL, that's what you're going to do. Okay, I see -2. So is -2, is it probably going to point up or down? The parabola is going to point, since it's negative, it's going to point down. Very good. Oops, sorry. It went down. How many spaces? 1 space over is a simple 2 spaces down. So on the IXL, the first one you guys are going to do is going to be up to 95, smart score 95, because I want you to make sure you guys got this easy, right? You get this done right the first time, you'll understand it. We can move on to harder things. But it's as simple as the A value tells you how fast you're growing. 1 step over, am I going to be up or down, and by how many spaces? In this case, -2 means I'm going to go 1 space over, -2 spaces down. -8 means from my center, for whatever the vertex is, 1 space over, -8 down. That's how fast this can be, understanding what that A value does. Now, I'm going to jump and talk about these other ones and look in our, let's go back and let's look at our example. So for these problems here, if my A is 1, the A value in front, that's how fast we're going. That's 1 space over, 1 space up. So I can graph it 1 space over, 1 space up on not only one side, but on both sides. 1 space over, 1 space up. 1 space over, 1 space up, right? That's as simple as it is. And then we can graph our parabola. Just draw the U as best as you can, going through those points. Now mine looks pretty nice because I've had 40 years of experience now. Let's look at the second one. Okay, our vertex is still at 2, -1. 2, -1. But what's the a value here? If you look at number 2, our a value is 2. So one step over, I'm not going to go one space up. I'm going to take 1, 2 spaces up. One space over, I'm going to take 1. It's almost like slope. It's almost like slope, except it's going to grow a lot faster than a line. Now, if you look at this graph on my right and on my left, does this look more narrow or more wide? I gotta be careful drawing this. It takes a little bit. Oh my goodness. Let's go the other way. Would you say this looks a little bit more narrow? I hope you would, because my graph is now twice as fast as the original graph. And then let's look at the third one. The third one is a is equal to 3. So one space over, I'm going to go up 1, 2, 3 spaces up. One space over, 1, 2, 3 spaces up. Hopefully you guys can see that's 1, 2, 3 spaces up. Now, I'm going to come down, and I think it's easier for me. And maybe, hopefully you guys can see that this graph is even more narrow. Okay. So let's give us another example of this. If I give you y is equal to -2x minus 2 squared minus 1, okay? So again, that's to remind ourselves what our h and k is. What are our variables? A is equal to, what's the number in front? That's -2. What's my h and k? As again, I need to remind you, it's x minus h squared plus k. So the negative stays. So that's going to be h is 2 and k is positive. So we're going to take out that negative with us. So we're going to take our trash out. We're going to pack out what we bring in. Our vertex is made up of h and k, which is 2 and -1. All right, so let's go ahead and graph it. Okay, 1, 2, -1, put a dot. Now, what is our a value going to make us do? Go up or down? Okay, up or down. And we said if a is negative, it's going to go down. So one step over, always do that one step. Do one step over, and then in this case, we're going to go 2 steps down. 1, 2. It's pretty much like slope, but don't draw a straight line. It's going to be a curved line. 1, and then 2 steps down. It's almost like slope. We're working at the same exact pattern, okay? And that's going to be a graph facing downward. Okay. Now, what if I have different styles of graphs? Does this pattern still work for us? And answer is yes, as long as I have it in this form. Now, again, the form is y is equal to a x minus h squared plus k. So you always have a squared and you always have a constant. So let's give ourselves an example of this. If I say y is equal to 3x squared plus 2, y is equal to 3x minus 2 squared. Or do these still fit the pattern? Do these still fit the pattern? Well, let's try. The first one, what is my a? What is my h? And what's my k? What is my a? What's my h? And my k? Now, these don't look exactly like, because I don't have the parentheses in the first one. So what do you think the h value is? What would the h value be if I wanted to cancel it out? If h was 0, 3x minus 0 squared plus 2, would you be okay that if I put 0, it would just be x squared? So that's what h is 0. If there is no middle term we have in this form, our h value is going to be 0. So this is a parabola that's 2 spaces up and 3 times as fast. So for this form here, it doesn't look exactly like my vertex form, but it actually is in vertex form. And the vertex form would tell me that my vertex is at 0, 2, 1, 2. It's a parabola 2 spaces up, but 1 space, 1, 2, 3 spaces up. That's super fast. 1, 1, 2, 3. That's super fast. Let's see if this fits the characteristics. If h was 0, I don't have the parentheses, and then my k value is 2. So my vertex is 0, 2, and the graph is 3 times as fast. What if I do have a parentheses, but I have no k value? There's no k value here. And what would we do here? Well, this is going to be 3, and it's going to be 2. And what number is here? That's a big fat 0. So my vertex is going to be 2, 0. Let's go and graph that. 2 spaces to the right, that's where my vertex is. My a value tells me how fast my graph grows. So we know this is a parabola because it's squared. We're going to go one step over. 1, 2, 3. 1, 2, 3. We have our parabola going up. Okay. So what if I give you an even easier problem than that? What if I write 3x squared? Does this fit the model of x minus h squared plus k? Does this fit the model? Well, do we have a k value? Nope, so that's going to be 0. And do we have a parentheses? Nope, that's also 0. So in this vertex model here, we have our a is 3, but our h and our k are both 0. And also, this is what we call our parent function of a parabola. A parabola x squared looks like what we expected. 1 space over, 1 space up, 2 spaces over, 4 spaces up. Now, what if I made this 3 times as fast? Instead of 1 step over, you would do 1 step over and then 1, 2, 3 spaces up. So this would actually be 3 times as fast. Oops. So this would be a more narrow graph. More narrow graph. 1 space over, 3 spaces up, which is what the a value does for us. So let's go ahead and graph 3 different versions of this. And let's see if we can figure out what the h and k for are all these 3. So if it's a y is equal to 2x minus 3 squared plus 1, okay? Y is equal to 2 x minus 5 squared, and y is equal to negative 1 or negative x, negative x squared plus 1. I want you to tell me, if you case can, what is the h? A, h, and k for all these. A, h, and k. A, h, and k. So these are the 3 different types that we've seen before. We're gonna, I can give you guys one more. So these are all the forms of the vertex, a vertex form that we can use. A is 2. What is the h? Because remember the pattern is x minus h squared plus k. The h is always going to be negative on us, so we have to flip it. So in this case, it's going to be positive 3. Our k is going to be positive 1. Right? Because that's a positive, it stays positive. Next one, what's my a value? 2, thank you. And then, do we have an h? Do we have a k? So we do have an h, that's going to be positive 5, and the k is nothing out there, right? So that's going to be a free 0 for us. The last one here, do we have an h? We don't, because we don't have a parentheses. That's going to be a 0 for us, and our k is 1, and a is going to be negative 1. Knowing these 3 characteristics, you can start your graph in a matter of seconds. This is my vertex. If we know our vertex, we know where to start the graph. Okay, the vertex is at 1, 2, 3, and 1. Okay, so the a value, 1 step over, how many steps up? Just like a line, 1 step over, 2 steps up. 1 step over, 2 steps up. One, 2, 3, 4, 5, 0. What's the a value here? 2, right? 1 step over, 2 steps up. 1 step over, 2 steps up. The last one on the right. Zero, 1, 0, 1. So in this case, 0, 1 would be -1, that's our A value. One step over, one step down. One step over, one step down. Okay. Now going backwards, what if I give you the graph? Could you tell me what the characteristics for it? And then you can write the equation. Let's go backwards now. If I cover that up, actually, you know what? Let's just go, I'll do a fresh start. 1, 2, 1, 2. And our first point is right here. Can you tell me what your H and K value is right now for this graph? What is the vertex of this graph? The characteristics, the X value is 2, and the Y value is 2. Are you guys okay? That's 2, 2? Thank you, 2, 2, perfect. That's my vertex. Now what's the A value? This is the one's a little harder, but you can count. From the vertex, how do I get to my first step point? One step over, one step down. Would you guys be okay with that? One step over, one step down? So it's almost like slope. One step over, one step down is going to be -1. One step over, one step down. So it's always from the vertex. We start from the vertex and then we decide, how do I get to that first step? So we actually have everything we need for our equation now. Y is equal to A, X minus H squared plus K. You might want to write that like 10 times. Y is equal to A is -1, X minus plug in H, plug in K, 2 squared plus 2. And we now have our equation. You can do this with any of our graphs. Okay, let me give you another one that looks very similar to that. Okay, this vertex is -1, 2, and we're going to go 1, 2. Tell me what the vertex of the graph is right now. Vertex. Hopefully you see the vertex is x's and y's. The x is -1, right? That's a -1. Our y is +2, right? We're looking for what this x and y point is. Well, that's the center, right? Bullseye, got it. Now, what is my A value? How fast or how slow does this graph grow? We just count it. One step over, would that be, oh, that's 2 spaces up. So for every step I take, well, this graph was twice the speed. One of the easiest way to read without really doing any other algebra is just counting the spaces. Counting the spaces. This is a double speed graph. One space over is 2 spaces up. That's double the speed. We have everything we need. Y is equal to A, X minus H squared plus K. Y is equal to A is, hey, that's just 2. I'm just copying numbers in. X minus, hey, that's -1. So I'm going to put negative here. -1 squared plus K, which is 2. The negatives cancel out. 2 X plus 1 squared plus 2. And that does fit our criteria for that. And that's what you guys are going to do on the second part of the IXL task. If you guys can go forward, you could definitely work on going backwards. Backwards always takes a little more time, takes a little more practice, but I want you guys to make sure you guys can see the patterns in this class, okay? All right, so let's go jump to the IXL real quick. So as these problems get harder, they're going to ask you, hey, what's H and K here? Hopefully you notice that there is no K, K is 0, and H, remember H is negative, X minus H, that's going to be 5. So to write this out real quick, so on a piece of paper, you might want to write it down. You're going to write, okay, A is 5. Okay, got it. And then my H and K, my vertex is at 5, 0, because H is 5 and we have no K, so it's going to be 0 for us. So this graph is going to be at 5, 0. Here's 5, 0 with an A value of 5, +5. One step over, 1, 2, 3, 4, 5. That's my parabola. So you're going to practice this so we won't make mistakes on this anymore. So let's go ahead and move this to, whoops. Okay, and we're going to move this second point. One step over, 1, 2, 3, 4, 5. Oops, a little off. 1. 5 spaces up. 5, 0. 5 spaces up, yep. This one is going to be, what do you think my vertex is? Positive 4 or negative 4 for my h value? Hopefully you see it's negative 4. And the k value is 0. My a value is negative 2, so one space over means I'm going to go 2 spaces down. So you could be really fast at these. This one is, do we have an h value? Nope, we do have a k value. So it's going to be 0, negative 7. 0, negative 7, you can see on the bottom because h is negative. And our a value is 3, so we're going to go one step over. We go 1, 2, 3. Okay, 0, negative 7. So this is how fast we're supposed to be able to do these. And hopefully with the practice from IXL, positive 6 is going to be right here. You guys can do these super fast. But of course, we make mistakes. Sometimes we're not paying attention. We miss it a little bit, and we can make some mistakes. But this is how fast you should be able to graph these once you figured it out. Now, this one is our h and k. Now, again, is the vertex at 1, negative 2? Are we going to take that number? Hopefully, you realize we don't take that number. We're going to take that at negative 1 and negative 2. So coming down here. The a value is invisible 1. What is it? All right.